So let's talk about Doppler effect. So what is Doppler effect? Initially, when we're talking about Doppler effect, I think the best example I can give you is let's assume to say you are walking along the road. Then there's a car which is coming toward you. As it is coming to you, it is blowing its horn, the water. Poop, 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 poop. Okay? So I'm going to give you two scenarios. Let's say you are just standing. You are not moving, you are just standing. And then the car is coming. As it is coming, it's blowing its horn. Poop, 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 water. And then now, what is happening is that as it is coming closer to you, you discover to say, do you expect the sound to increase or to reduce? At the same time, as it is going, in that case, meaning the car is coming toward you. Okay? Now, the car is emitting sound. That water, poop, 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 that is emitting sound. Okay? So it's like the car is emitting sound. Now, an object which emits sound is what we call the source. So in that case, I've given you two scenarios. Here there is a car, okay? And then you are just standing. You are the observer. Here the thing. So this is the car. So as it is coming toward you, it is blowing its horn. Then you are just standing here. You are the observer. You are the observer. Now I want you to understand this. I've given you two scenarios. You are standing there and the car is coming toward you. Okay? Now, another scenario, let's say you are standing here and then the car is moving away from you. There are two scenarios there. So, as the car is moving toward you, this car is going to have the velocity. The velocity of this car, we are going to call it the velocity of the source, which is Vs. It's supposed to have the frequency. This frequency, I'm going to call it the frequency of the source. As you are standing, you are not moving, but we expect you to have the velocity. That velocity, will call it the velocity of the observer. At the same time, you are going to have the frequency, which we are going to call the frequency of the observer. Now, since we are talking about the frequency, the sound which you are going to be hearing, you yourself here as you are standing, is going to be traveling in air. So the speed of sound in air, we always consider the temperature to be at 20 degrees Celsius. Last time I mentioned this. We always consider, that is, if they have not mentioned anything about the temperature, then consider that that temperature is at 20 degrees Celsius. The 20 degrees Celsius, the speed of sound in air is always 343 meters per second. That is what you need to know. Now, like I've said, I'm going to simplify this topic such that I think we are going to do it in just 20 minutes and then we'll start now solving questions anyway. So just know that the source is going to have the velocity of the source. The frequency, we're going to have also the frequency of the source. At the same time, we're going to have the frequency of the observer, which is FO, the velocity of the observer, which is VO. As simple as that. What next? Now, you need to know, there are only two things here. You need to know the sign of the velocity of the observer as it is approaching there, if it is going toward the observer or away from the observer. Now, the general formula which you need to know under Doppler effect is this one. So I think I'll explain everything from this formula, which is the velocity of the observer is given by the velocity of the source, open brackets. Then here we're going to say the velocity, which is the speed of sound in air, plus or minus the Vs or the Vo. Let me start with the Vo. I divide this by, again, the velocity, which is the 343, Then on top here there is plus or minus. On the denominator is the opposite. It's going to be minus or plus. Then the velocity of the source. Like that. This is the general formula. This is the formula we're going to be using to answer all the questions. Like the question which I gave you in your test 1, it required you to use this formula, but now you need to know, are you supposed to get the VO as positive or the VO as negative? That is the trick now. That is what you need to know. So far so good, right? In a case where you have been given the velocity to be in kilometers per hour, you have to convert that velocity to meters per second. For example, let's say we have been given um, the velocity of the source to be maybe 1000 kilometers per hour. Meaning I have to change this now from kilometers per hour to meters per second. Using dimension analysis from semester 1, we know that we can say 1000 kilometers in 1 hour. I'll say times. I'll set the units in such a way that they should cancel each other. So I'm going to say in 1 kilometer, how many meters do we have? We have 1000. Meaning, in this case, the kilometers and kilometers will go. I've converted now from kilometers to meters, but I still have hour down here. So I'll say times. Then I'll say in 1 hour, I'm setting the units in such a way so that this and that should be cancelled. In 1 hour, how many minutes do we have? We have 60 minutes. But we are not interested in minutes. Again, I have to convert these minutes. I'll say in 1 minute, how many seconds do we have? 60 seconds. So at this point, I can clearly see that hour and hour can cancel, minutes and minutes can cancel. Then you get your calculator. You say 1000 times 1000 divided by 60 times 60 is 3600. Meaning that this in meters per second is 277.8 meters per second. So if you've been given the speed to be in kilometers per hour, you have to convert that from kilometers per hour to meters per second. Now, let's talk more about this formula. We are saying VO is equal to VS, open brackets, V plus or minus VO, down V minus plus VS. Let's talk more about this formula. How can I use, or how can I know that here the velocity of the observer is positive or here the velocity of the observer is negative? How can I know? So here is a trick thing which you need to know. If you read the question and then you have been told that the observer is moving toward the source, get me right here. This is the first point. I think this one you should know. Observer moving toward the source. So if the observer is moving toward the source, what you should know is that the velocity of the observer is going to be positive. So if you read the question and then they are talking about the observer moving toward the source and the source is not moving, in that case the VO is always positive. Now, when you know that the velocity of the observer is positive, as long as you know the top part, then the down part is going to be negative. That's how it is. So if you discover that the top part is negative, so the down part will go also with the down part. The top part will also go with the top part. That's how it is. But let me give you another scenario. Then when the observer is moving away, that is 2. When the observer, it's just the opposite of the first point. When the observer moves away from the source, the VO is negative. Is that okay? Exactly. Then now point 3. Now I'll talk about the VS. So now point 3 is if the source is moving toward the observer. If the source is moving toward the observer, the VO, oh, the VS, we're talking about the VS, sorry. The VS is going to be positive. Okay? Then the next one is, which is this is supposed to be the third one, this is the fourth one. So is when the source moves away, it's the same thing. So if the source moves away from the observer, the velocity of the source is negative. Now, I want to explain when I say it's moving toward the source, what are we expecting? Moving away from the source, what are we expecting? Like I've said earlier, if you are standing, the car is moving toward you. The driver is blowing the water. Poo, 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 poo. As it is approaching you, the frequency has to increase because it is approaching you. Why are we saying the frequency has to increase? I think I can explain better from here. Remember, the velocity is given by the frequency times this. Remember that if I make the frequency as a subject of formula, so it's going to be frequency is equal to V divided by lambda. Lambda in this case is what? It's the distance we're talking about. Okay? It's a distance we're talking about here. Okay, it's the distance we're talking about here. Now, what is happening? So you can clearly see that the frequency, this is the distance we're talking about here. So now I'm saying if this is the car, okay, it's moving toward you, meaning we expect the distance to reduce here. So if the lambda is reducing, what do we expect? The frequency has to increase. So if lambda goes down, the frequency goes up. So when the car is approaching you, when the source is approaching the observer, we expect the frequency to increase. Okay? So before you even solve the question, you'll be able to know that in this case, this frequency which I'm trying to find here is supposed to increase or is supposed to reduce. If the car is moving away from you, this lambda is going to increase. If the lambda increases, the frequency goes down. So definitely the frequency has to reduce. Okay? Does that make sense? Yes, it does. Now, another thing here is when we are talking about, we have been mentioning about this. We have been mentioning about toward and away. Okay? So the word toward, when we are talking about toward, okay, it is associated with increased in frequency. Increased frequency. When we're talking about toward, meaning we're talking about the increase in frequency. Away is going to be what? Decrease in what? Frequency. As simple as that. Another thing here is this. Another point which they like bringing here is this point. I've given you 4 cases where when they tell that it's moving away or the source is moving what, those are also very important. But so here are the questions now. So the first question is saying 2 trains on separate track move toward each other. Move toward each other. What comes in your mind? Move toward each other. What will be the sign for the velocity of the observer? Then the source. Okay, let's continue. From just the statement, the first statement, you can't really know. We have got 2 trains, they're moving toward each other. You can't really know which one is the source, which one is the observer. Continue reading the question. Train 1 has a speed of 1.3 times 10 to the power 2 kilometers per hour. And I mentioned to say, if you have been given the speed in kilometers per hour, because the velocity, the speed of sound in air is always 343 meters per second, you have to convert this from kilometers per hour to meters per second. As simple as that. Again, from there you can't really know that this train is either the source or the observer. Let's continue reading the question. Train 2 has a speed of 90 kilometers per hour. Again, from there we can't know. Full stop. Train 2 blows its horn, emitting a frequency of, get me right there, the one which is emitting or blowing the horn or emitting the frequency, I said is what? Exactly, it's the source. Then what is the frequency heard by the engineer on train 1? Now, we have been told that train 2 is the source. So I'm going to say I need to come up with a free body diagram. Okay? I'm going to say this is train 1. Okay? I put it here. So train 1 is the observer. So we have been told that we don't know the frequency of the observer, is the one we want to find. The velocity of the observer, we have been told that it is 1.30 times 10 raised to the power 2 kilometers per hour. We jump. We go to another train, which is train 2, and we have been told that these 2 guys are moving toward each other. So if they are moving toward each other, this is going to be positive. Then the frequency of the source we have is going to be what? It's going to be 5.00 times 10 raised to the power 2 hertz. But the velocity of the observer is 90 kilometers per hour. So since they are moving toward each other, this has to be negative. So since this is negative, the formula which I'm going to use is this. VO or V, since the VO has to be negative, on top I'm going to put minus. So it's going to be minus V O and then V plus Vs, like that. Okay? Now let's try to plug in the values. But first of all, we have to convert this from kilometers per hour to kilometers per second. Let's start with this one. So this is going to be 1.30 times 10 raised to the power 2 kilometers divided by 1 hour times. In 1 kilometer, how many minutes do we have? We have 1,000. Sorry, how many meters do we have? We have 1,000. In 1 hour, how many seconds do we have? 3,600 seconds. At this point, hour and hour can go, kilometers and kilometers can go. Grab your calculator. 1.3 times 10 to the power 2 times 1,000 divided by 3,600. I'm getting 36.11 meters per second. I'll come here and put it here. Let's go ahead and convert now this other one, 90. So 90 kilometers per 1 hour times. Set the units in such a way that they should cancel each other. So 1,000 meter. In 1 hour, we have 3,600 seconds. Cancel this. So 90 times 1,000 divided by 3,600, 25. So now I'm getting this as my 25 meters per second. Confirm if you have a calculator. Perfect. We want to find the frequency of the observer. The question is, these two guys were moving toward each other. Get me right there. These guys were moving toward each other. The question which I'm going to pose is, do we expect the frequency of the observer to be greater than the frequency of the source from the explanation which I've given you? Okay. It will be greater, right? So if I ask you the reason why it's going to be greater, you can tell me. Those are questions which you have to expect in your MCQ. The distance was reducing, right? Okay, perfect. Let's go ahead. And if we discover, do you know that this 5.00 is the same as 500, right? So as we are solving, if we find that the answer is less than 500, then it's definitely wrong, right? Yes, it's wrong. So let's plug in the values. We see. So this is the 500. Then if this V is always 343 minus the VO. The VO is 25 divided by the VS. Sorry, this is going to be also 340, then plus. Then you have 36.11, like that. Let's see. VO will be equal to, let's just first write a 500. Then down here we say a 343 minus 25, 318. I divide this by 343 plus 36.11. Then down here I have 379.11, like that. So I'll say 318 divided by 379.11. I'm getting 0. I'm getting 0. What? I'm getting 0. Haven't I swapped them? Which one is the velocity of the source and which one is the velocity of the observer? I've swapped them. Have you seen here? Here there is Vs, then here there is Vo. I'm supposed to put this here and this there. Have you seen? Yeah, so I'm supposed to put, so let's just do this. Let's write, so the V, I'm supposed to write Vo, the velocity of the observer, which is 25, right? Then the velocity of the source should be Vs, which is 36.11. Yes. But Kylie, I swapped them. Do you see what happened? I swapped these, whereby, do you know that this is train 1, right? Oh, train 1 is the observer, right? Oh, okay. Okay. So this is supposed to be 36, right? Okay, thank you. Then this should be 25, right? So I just swapped these ones, right? And not the figures. So 25. Okay, perfect. Meaning even there we have swapped them, right? So we are supposed to say the frequency of the observer should be, I've said 5.00 times 10 to the power 2 is the same as 500, but you can also put the same, like 5.00 times 10 to the power, then 343 minus the VO is 36.11, then here 343 plus the VO is what, 25, or the VS, sorry. So we'll have this. Then the one which was bottom there, which was 370 what, 3, so I'll have 500 open brackets. This minus that one is supposed to be 379.11. Then the down part should be the one we found, which is 31.8, 318, sorry, like that. So I'm going to say 379.11 divided by 318. The answer I get times 500. Confirm with me. Mhm. Are you sure? Okay, okay. So 343. Come on. We said when these two guys they are moving toward each other, we said the velocity of the of the observer should be what? The observer should be negative, then the source will be positive. Then I swapped. If I said that, then I swapped, because what is happening is when the observer and the source they are moving toward each other, the velocity of the source should be positive. Why is it positive? Because it's more like the source is also moving toward, so we are interested with the source. The source, I've said, okay, the observer is also walking. Okay, so the velocity of the observer should be positive, so I swapped. Sorry for that. When these two guys are moving toward each other, the velocity of the observer should be positive and the velocity of the source should be negative. Then the opposite is true. If they are moving away from each other, the velocity of the source, sorry, the velocity of the observer, I have to start with the observer. The velocity of the observer should be negative, the velocity of the source should be positive. I don't know if I've, let me just go back to the previous board where I was talking about, which point was that, eh? Uh-huh. Do you remember this? In fact, we can just get it from here. I think the first part where I said if the observer is moving toward the source, the VO is positive. Get me right there. You remember, right? The first point. The observer moving toward the source, the VO is positive. Now let's go to the source. If the source is moving, where is it? If the source is moving toward the observer, the Vs is positive. Now in this case, it's when the observer is at stationary. So like I've said, like, remember I said the moment you discover one thing, since the observer is moving toward the source, we know that the VO is going to be positive. When you know just one thing, the other one is going to be easy for you to know. You get, right? That's why I said they are supposed to be 5. So the number 5, I'm supposed to change that point. Where is it? I've I've deleted that part. Anyway, let me put it here. I can even put it here. So correction. I'll put it here. So this is, in fact, this is the very important one. It's the one they like using it. So if the observer and the source are moving toward each other, the VO is positive and Vs is negative. Then the opposite is true. If they are moving away from each other, this is going to be negative, that is going to be positive. Have I made myself clear there? Yes, meaning that this part here is just okay, right? No, this part is supposed to be positive because they are moving toward each other. So the VO should be positive. The VO should be positive and the VS negative. That's what we have said, right? Yes, the formula will change. So I'm supposed to put this should be positive, this should be negative. So this should be positive, this should be negative, like that. Okay. So if you master that, I think it will be easy for you to do OSIS. Meaning we are just okay there. So if we do, I said I'm getting 596.08. And for sure, from your explanation, you told me to say this has to increase because the distance is reducing. If these two guys were moving away from each other, this was supposed to reduce. The VO was supposed to reduce. Any question? Okay. So now, I don't know if maybe let's try to solve this one as well. The siren of a police of moving police car emit a frequency of emit a frequency. What's that? Is that the observer or the source? So our source is emitting a frequency of the source is 440 hertz. Now the rest is going to be observer. So the observer, the remaining frequency, and in fact here they say a stationary. Aha, this is the question I wanted. A stationary observer hears a frequency of 494 hertz. I want you to get me right there. When we say stationary, meaning it's not moving, right? Aha. Now, if it's not moving, meaning what is the velocity at that point? What is the velocity of the observer? The observer is not moving. What would be the velocity of the observer? If something is not moving, it is a stationary. What is the velocity? Okay, I'm asking about the figure. If the object is not moving, it will be zero. Exactly. Then now the question continues. The speed of the sound in air is, we have been told the speed of sound, and we know that always it's just like that, 340 meters per second. Now get me right there. So this is the source, okay? It's the one which is emitting the frequency. It's like it's moving toward the what? The observer, and the observer is just at stationary. So it is moving toward the observer. What do we expect with the velocity of the source? If the source is moving toward the observer, what did I say? If the source is moving toward the observer, it will be negative. Are you sure? The source is going to be negative. Go back to your notes, the ones I gave you. That's what I said. I said, in this case, the source is the one which is moving, right? The source is moving toward the observer. So which one are we getting? The source is moving toward the observer. So is the velocity of the source is going to be negative or positive? No, check your notes. Point 3. Read point 3. Mhm. Uh-huh. Why? I want you to read what is happening, like the full statement which I gave you. Okay, you can read from here. Mhm. So isn't it the same with the question we're trying to solve here? The source is moving toward the observer. The observer is at stationary. So are you telling me that the velocity of the source is going to be negative? Hmm? You're confused. Exactly. So if this is my formula, if this is my formula, no. If down we have, okay. Let's do this. We are saying V plus or minus, then VO, then down here it is V minus plus Vs. So on top, okay, let's start with, since we are interested in the source in this case, because this is at stationary, and it is, if it is at stationary, it will not affect anything, and you need to know the other one, because zero will not affect anything. Even if you put minus or plus, it's not going to affect anything. You know that, right? Now concentrate on the other one. So the velocity of the source is moving toward the observer. What would be the velocity of the source? Negative, positive? Mhm. In short, what is happening here is this. If something is at stationary, that thing which is moving toward the other one which is at stationary, it will always be positive. The one which is moving. So point three I've told you that if the source is moving toward the observer, the velocity of the source is positive. Meaning, if here is positive, here on top is going to be negative. Yes, it's going to be negative. So now we are trying, the question is, what could be the speed of the direction, the speed and the direction of the moving car? So we are trying to find the speed now, the velocity of the source. Initially here we have been told already that this observer is at stationary. Okay? And from your observation here, the frequency, this is the frequency which was being emitted. But the source, the observer, heard this frequency of 494. It increased, meaning it was moving toward the. So if it was moving toward the answers here, you can clearly see that the answers, all the answers which are talking about away from the observer, they are wrong. Okay? So like for example, before I solve this, I can clearly see that this is wrong because it's talking about away, and here we're talking about toward because the source is moving toward the observer. So this B is wrong before I even solve. Then again, D is also wrong. The only options now I'm remaining with is A and C. So if I get 37 or if I get 42, then C is the answer. If I get 37, A is the answer. As simple as that. Let's go ahead and plug in the values. We see what we're going to have. So we'll say, since the source was moving toward the observer, we'll, we'll use this formula. V minus VO divided by V plus VS. And our goal is to find the VS. So the velocity of the observer or the frequency of the observer is 494. Then this is 440. This is 344. 343 minus 0. 343 plus what is the velocity of the source? We don't know. It's the one we are trying to find. So what we're going to have now, my dear, is 494 is going to be it's the same as I just do this times 343. So I'll say 440 times 343, which is 150,920. I divide this by 343 plus Vs. I can cross multiply. So if I cross multiply, I'll say now 494 times 443. Oh, 343. Which is going to give me, I can write it here. It's giving me 169,442. Then plus 494 times Vs is 494 Vs. Should be equal to the 150 is going to be equal to 150,920, like that. Shift this to the other side. Okay? So if we shift that to the other side, what are we going to have? What are we going to have? We are going to have 49 oh 494 Vs should be equal to 150. I don't know if you are, if you're also following. If you have a calculator, you can You can just help me to punch. So we have 150, and then what else are we going to have? 1590 minus, I get now this one, 169,442. So if I do minus, I'll end up having what? Negative 18,522. Divide it by 494. Negative negative 39. 37.5 meters per second. Okay, it was MCQ, so I think the negative part you can just ignore it. But the reason why we had to eliminate, so in this case we are dealing with 37, right? What is the difference between B and D? No, as in they're the same, right? I mean B and D, they're the same, because this is saying direct away from the observer. Again, this one is saying direct away from the, oh, they're the same. So it has to be toward the observer. It is moving toward the observer. So the correct answer was what? It was M. So that is it for Doppler